We are starting our notes on rational expressions. So if you remember your 6th grade math, 5th grade math, somewhere in there, I don't know, you had to deal with fractions. So now we are starting to deal with fractions using polynomials, monomials and polynomials. So really this whole unit is like about fractions. Okay. So a rational expression is simplified when it has no more common factors. So yes, factors or factoring is a big piece of this unit. So no other factors other than 1. Okay. You can only divide out common factors, so they have to be factors. So they have to be expressions that you can factor out and not individual terms. All right. So to do this, you must completely factor the numerator and denominator. That's the first step. Make sure you always completely factor and then cancel out anything that's the same in the numerator and denominator. So when we talk about individual terms, I can't cross out an x here and an x there because this is part of an expression. I need to factor first. So you got to remember all your factoring rules. The first rule of factoring is your common factor. So in the numerator, we just have f of 4x. In the denominator, I have a common 4x that comes out of both terms. That will leave me with an x plus x squared plus 3. So if I have an x squared plus 3, I can look at this and the 4x's will cancel out. And that just leaves me with that one term in the denominator, and the numerator becomes 1 because it canceled out. So this is 1. So we have 1 over x squared plus 3, and that is all we can do with that. We can't do anything more. Can't factor it anymore or anything like that. All right, let's look at our second example. Our second example, we need to factor this denominator. So the numerator is going to stay the same, x plus 3. However, the denominator now, when I find the factors of this, two numbers that multiply to make 6, add up to 5, well, it's going to be 3 and 2. So x plus 2, and it's a sum, so they're both going to be positive, because it's a positive middle term, x plus 3. And then we have x plus 3 and x plus 3 that cancel out. So the numerator becomes 1, and what is left in the denominator is x plus 2. Let's look at example number 3. Example number 3, now we need to factor in the numerator, but we still got to follow our rule. Our first rule is to take out the GCF. That's going to be 3. That leaves me with x squared minus x minus 2. Now the denominator is a perfect square binomial, so let's go ahead and factor that. So it's x minus 2 times x minus, or plus 2. Negative 2 times 2 gives us our negative 4. And if you think about the middle, it's going to be 0. But we aren't fully factored here, so I don't want to look to start to cancel anything until I am fully factored. Let's go ahead and factor this second term. So in the numerator, we need to go ahead and factor the quadratic here. So the 3 stays, and we have x, and then it's going to be negative 2, and then x plus 1. So in the denominator, I'm going to have x minus 2, x plus 2. So if I look, I'm looking for things that are the same in the denominator. 3, nope, no 3 down there. X minus 2, there's x minus 2. X plus 1, there's no x plus 1 down there. So then that means my final expression is 3x plus 1 times x plus 1 divided by x plus 2. And that would be our final answer for that one.